Right. So in the previous class, we learned a very good introduction to segment routing. We learned why we need segment routing and what is the main difference between segment routing and normal MPLS. And we saw the global block, local block, segment ID, adjacent ID. We also saw the logic behind segment routing. What segment routing does is it adds the stack of labels as the traffic enters. The stack of label that steers the packet through a particular path to the destination. So as the traffic goes from one point to another, the top label will be removed, popped, and according to the available top layer label, it moves the packet towards the direction. We saw with the picture as an example. As a continuation, we are going to understand how the data plane works. Segment routing uses MPLS data plane. Segment routing version 6, no need for MPLS. It will use the extended header in the IPv6. But for IPv4, MPLS is still used. But what is not used is LDP. Why LDP is not needed? To distribute the label, segment routing relies on the IGP, the OSPF, the ISIs. Even this OSPF and ISIS are extendable headers. By extending the LSA or LSP in ISIS, the labels are carried, distributed, the route informations are distributed. So let's see what it is here for MPLS data plane under the segment routing. As we said just now, segment routing leverages existing MPLS data plane. So you need to enable MPLS. And also we are going to see how to verify the segment routing MPLS forwarding table. MPLS data plane operations. Segment routing uses the existing MPLS database where we call segment instead of label, and instead of calling label stack, we call it a segment list. Uses PHP and explicit null functionality, same like MPLS. Even after segment routing on MPLS, we have that same MPLS behavior. PHP happens. What is PHP, Anbu?
Penalty to the party. It will remove the labels before it
sends to the final destination. Correct. For that, the explicit null notification comes that makes the n-1, the router, to pop the label. So if you do not want the PHP to happen, you can disable by enabling explicit null label. MPLS data plane operation. A node imposes prefix SIG-ID label on the packet if the destination itself or the next hop that the destination resolves on matches forwarding equivalence class FEC with prefix SID. What does that mean? A packet want to go to a destination. For that destination, I'm seeing a prefix SID. In our example in the previous class, we saw 16,004. Actually, it was going to router 5. To go to router 5, it was going to router 4, 16,004, and then taking the adjacent SIG ID and then deliver to router 5. So for each destination, there is going to be a prefix SIG ID. If there is a prefix SIG ID for a destination is matched in the segment routing forwarding table, which is called as forwarding equivalence class, FEC, the packets are going to be routed using the label. So this shows, the compatibility between MPLS LDP label and the SR SIG ID. See the last line, the node is configured to prefer SR label imposition only when it does not have an associated LDP label. Okay. You don't need to get confused with the last point too much. It is only, if you have a mixed environment. I have MPLS LDP as well as segment routing. Some routers are not segment routing. They are only MPLS LDP. Some routers are MPLS LDP and SR, and some are only SR. When you have such mixed environment, you will need this. Now,
Sir, prefix is exactly
look here. We have router 4 with a prefix SIG ID 16,004. 16,004. Why? Because for this router, index value is given as 4. And this is the prefix. And the prefix SIG ID is this. What will be the prefix SIG ID of this one? Let's say the loopback address is 1.1.1.3 here. If the index value is 3, then it will be 16,003. So every router knows where is 16,004 and where is 16,003. So when a packet arrives to this router, which wants to go to the loopback interface address of router 4, this prefix, the prefix SIG ID 16,004 is attached. It goes here. This guy also knows where is 16,004. So he sends here. And this guy will do PHP. It pops this and send it here with explicit null flag 0. Now, did you understand prefix SIG ID?
yes.
Okay. So, even in segment routing MPLS, you can see that push, swap, and pop. But they're not going to swap with a different label. It is going to be the same label swapped. In normal MPLS LDP, you will have different label. This side different label, this side different label. So it will come like 17 and then it will swap it with 34. That is how it used to be. But in segment routing, the labels are same even though it is same. Swapping happens. Why? Because you are using the existing MPLS data plane. MPLS data plane works like this. What? Push, swap, and pop. So that same procedure is still followed even in segment routing MPLS because it is MPLS label. Okay, what is important is every router should be SR enabled, and there is no need for LDP. So look at this router. When you type show IPsec 1.1.1.4, which is the prefix of router 4, you can see that the label that is attached is 16004, and the interface via which it is going to go is this one, G0/0/0/0/0, and the next stop is this 99.2. See, the local label is also this, the label imposed is also this. A push operation happens here. Label is attached, pushed. This is IPv6, and don't get into IPv6 now. This is for prefix IPv6. The previous one is for IPv4. Focus on IPv4. Now, when you check this command, the show MPLS forwarding table for label 16004, it shows that the local label 16004, swapping label is 16004, where you are seeing in router 2. So it's going to swap this label to this label and send it to router 3, and sending it out via G0/0/0/1. The same like, show MPLS forwarding table. You are just filtering through one label. Now, when you go to router 3, what you see, it says that if the packet comes in this label, you have to pop it and send it to router 4. Pop operation. The previous page, swap operation. The first page, push operation. Push, swap, and pop. Same like MPLS. Because you know MPLS, you understand this. And when the packet arrives to router 4, it comes without any segment ID. It just forwards based on the IP address. Now, explicit null behavior. Explicit null is configurable for prefix SID. If the originator of the prefix SID want to receive the packet with original explicit null, for example, if you have QoS, you need that. So we can set the E flag, which is nothing but explicit flag, in the prefix segment ID. If you see in the previous case, it is off. In all the cases, it is off. Okay, so if you want that, you can enable it. This causes PHP to swap the prefix SID with explicit null instead of popping the label. So it won't pop the label if you enable this. Even to the final router here, the pop is happening before sending to router 4. When you enable this explicit null, the pop won't happen. See, this is the command. On router 1, this is for router 1. How do I know? Because I see 1. Prefix SID absolute 16001 explicit null, meaning while advertising, tell that I want label, don't pop. See, it is not popping, it is sending explicit null value. In the previous case, it was popping off. No MPLS header. Here you have the header, but with null in it. Explicit null. See the difference in the output. Pop. But here, null. Why you need that? As I said, you need this header for the QoS. QoS is marked, and if you pop the label, QoS will disappear. I want the QoS. Even though it is explicit null, even though it is a null label, why I'm expecting that header there for QoS. Right, whenever we do QoS, not IP, but MPLS QoS, you need the MPLS header so that the QoS 3-bit experimental bit will be carried. This is a well-known topology for you because we all have done VRF, layer 3, layer 3 MPLS VPN. Have we done layer 3 MPLS VPN? Please answer.
Yes. Yes.
Thank you. என்ன அன்புகிட்டது மட்டும் எஸ் என்னைக்கும் வரதில்லை ஏன் அது?
Yes, yes.
Now this is a similar scenario. Simple and efficient transport of MPLS service. The prefix SID of router 2 is 16,002. And this is the prefix to identify this router. Customer is in VRF red and the remote customer of VRF red. Traffic comes here and then takes the VPN. And now router 1 is seeing equal cost path to reach this remote PE. So it will use both the paths. All that it needs to do is deliver the packet to 16,002. So it comes here and then pops the label off and delivers here. MPLS service rides on prefix segment ID. So here it is only prefix segment ID makes this routing happens. But the advantage is this. The difference is in MPLS layer 3 VPN we had LDP to do this. We get the same output but without LDP. One less protocol. We were doing this successfully in the previous MPLS classes, but LDP was there to do this. Now you achieve the same result but no LDP. The free router is running SR. Verifying IP forwarding global table. So I'm in router 1. I'm checking for router 2's prefix. Right? So what I see is there are two paths. To go to this router 2, you see, from router 1 to go to router 2, how many paths? Two paths. 1.1.1.2. It has got two paths, one via router 3, another via router 5. You see here? Router 3 and router 5. Okay. So The label that it is imposed, it's the same label but goes to different gateway. Goes to router 3 and router 5, and router 3 and router 5 knows where is 16.16,002. So router 3 forwards to this guy, router 5 forwards to this guy, and router 4 forwards to this guy. And here in this example, no adjacent SIG-ID is involved. Only in the previous chapter we learned that is to understand that we have global SIG-ID as well as local SIG-ID called adjacent SIG-ID. But in this case, there is no many stack of labels. There is only one label called 16,002 attached when the packet is going out from router 1 towards 3 and 4. Oh, sorry, 3 and 5. Just using that one label, the packet goes up to router 2. Now, when we type the ceph command table, see that the output is here on router 1. Show ceph, this one we put, show ceph red for one particular VRF and for one particular network we are asking. Actually, this network is in router 2. See, 10 network. It's coming via router 2 only. That's a VPN service. So it shows now, okay, you want to go to this network via VRF. Don't worry, I'll let you know how to go there. For that, you need to go to router 2 first. For going to router 2, this is the label. And using that label, you can go to router 2, and the next stop is 3 and 6. 3. It goes to router label imposed is this. And then 90,001. This looks like one adjacent SIG-ID. Maybe this is from different picture. It says the next stop, it goes to this using this label, and it should exit to go to 3, that is right, and it should be to 5 according to the picture. But IP address I'm seeing as 6. I don't know why they give 6 here. It should be 5.5. Yeah, 99. Maybe they are referring to different topology. No, it's not a different topology. That's a mistake. Here they made it correct. See, this is 99.133. 99.133 is perfect. And the another next hop is 99.155. I don't know why it comes 66. 6.6. That's wrong. That's a mistake they did while preparing the document. Now, 2 paths. So it says, I'm using equal cost multipathing. It uses both the paths. The forwarding table. Show MPLS forwardings for each destination. The index value is seen here, which means 16,001. Index value 5 means 16,005. Index value 10 means 16,010. For these two networks, it is popping out because that's the immediate router. See, I'm showing you in router 3. Router 3 to go to 24 is nothing but the beginning of the adjacent SIG-ID. 32 is between 3 and 2. So this is directly connected. That is why it is popping. And this is also directly connected 34. That is why it is popping. This is called as adjacent SIG-ID. They are directly connected. But these are not adjacent SIG-IDs. These are global. Right? To go to router 5, go to router 2, it shows. See, to go to router 10, 16,010, we have 2 paths, 2 entries. One via gig 000, you will go to router 2, which is this path. Another via gig 001, which is via router 4, this path. Praise the Lord. Okay, so now this is how MPLS forwarding table looks after you enable segment routing. Without segment routing, we used to see small number as a label. But for segment routing, 16,000 to 23,999, 8,000 labels are reserved. And for adjacent SIG ID, it is starting from 24,000 onwards. Any question on this page? Okay, so here we have an example for PHP. This is popping because it goes to router 4. That's the immediate guy. And for router 2, explicit null is enabled, so it is not popping. That's the example. Here you have equal cost multipathing example to go to router 10, which we just discussed. All right. So this chapter was again a kind of MPLS class, but slightly different. What the push pop swap happens here, but the swapping is not to a new label, it's to the same label. And then PHP is also available here, same like MPLS, LDP. Even in segment routing MPLS data plane, you have the popping. But if you do not want to pop for some reason, what reason? You want that experimental bit to be available for QoS. So what you can do is you can enable explicit null stuff so that the header will be carried like this. So instead of popping, this is the command to enable that. When you assign the SIG ID, you also mention I want explicit null. When you do that, the header won't be removed, popped. It won't be popped. You will have a null value, but the header will be still there, so that the other bits like experimental bit can be used. Here, this shows the example to understand the difference between L3 VPN with MPLS only with segment routing. With segment routing, we achieve the same result what we got in MPLS MPBGP without LDP here. And then ECMP, all the stuff we saw. That's the end of this chapter 2. Chapter 2 in segment routing is over. These points, I think, if you read now, you will understand. The node imposes prefix SID label on the packet if the destination is matching with the prefix SID and all the downstream neighbors are running SR. And if you have MPLS LDP, it will use MPLS LDP, but if it doesn't exist, then it will use SR. All right? Okay.